Hi, my name is Aaron, and today I'll be talking to you about summarizing therapy transcripts. So it's no secret that there's a shortage of qualified therapists in the US relative to the number of people who need mental health care. Add to this isolation caused by COVID-19, and you get a situation where people are not getting the mental health care they need, especially in a time like this. However, over the last few years, there have been more and more chatbots that aim to not do therapy but augment the therapeutic process by giving people someone or something to talk to in between therapy appointments. But we saw a problem with this. The client is sharing information with the chatbot that they'll end up repeating in front of their therapist. And meanwhile, the therapist has to get to know someone really well over about an hour a week on Zoom. So we set out to design an algorithm that would convert transcripts of therapy sessions into executive summaries for therapists. So we ended up finding our data on counselchat.com, which is a sort of bulletin board where people ask mental health questions and qualified therapists answer them. So it's an expert question and answer network. Since we had this data, we pivoted. And we decided to define a learning task where we summarize all of the therapist responses into a sort of consensus answer for each question. And as we looked into the model architectures, we saw that unsupervised summarization basically fell into two categories: extractive summarization and abstractive summarization. They're different in that extractive summaries take words strictly out of the text you're summarizing, but abstractive approaches can use whatever vocabulary they were initially trained on, not just what's in the prompt. And we identified 3 papers that looked promising, 2 in the extractive camp and 1 in the abstractive camp. And we had time to implement one of them. However, we discuss all 3 approaches in the paper. So just to briefly sketch out some of the architecture, the extractive approach we evaluated used word embeddings, and this was its encoder architecture. And meanwhile, the abstractive approach featured an encoder-decoder tied to a summary generator, and again, more details are in the paper. So just to give you an idea of what the data looks like, here's a screenshot of our data set. It's a CSV mapping multiple answers to a single question. And we originally planned to compare the outputs of all 3 of these models using word overlap with the originals as well as BLEU scores, but we ran into some logistical issues and had time to only implement 1 model. But you can still see some interesting things here. So the summary starts out reasonably, but it kind of seems to unravel near the end. We identified some possible remedies for that in the paper. And it's a work in progress. But all the same, I thank you for your time.